All right, so bell work. They had a couple vocabulary words in there for you. I don't have my book, but the first vocabulary word was converge. Yes. Actually, no. Even before that, number one. Number one. The question was, what is an which one of those is infinite series? Is the first one an infinite series?
No.
No? Why not?
Oh,
Hold on.
yeah.
Why is it not?
I don't know what it is.
Well, what does the dot 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 mean?
It continues on.
It continues on, doesn't it? So that means that it goes on forever. So that means it is infinite, correct? What about the? But is it a series? It's not a series. What makes it a series? Jacob? Thanks for closing your laptop. What makes it a series? Yeah. So a sequence is. Give me a second. Let me see if I can do the whole switcheroo here. A series is the sequence is going to be just an ordered list of numbers, which is what the first problem is. Correct? It's just an ordered list of numbers. A series is going to be the sum of those numbers. So if you don't see plus 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 plus, then it is not. Then it's not going to be a series. So the first one, take a look at that. It says, I believe. Let me add a page here. What is the numbers? 3, 9, whatever. But it goes like this, right? There's no pluses in there. There's no addition. So it is not going to be. It's not going to be a. This makes it a sequence. Now, if we had 3 plus 9 plus, what is it, 15, dot, 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 then that is a series. Okay? Series meaning that it's the sum of a sequence. Okay? All right, what was the other thing? The next one?
5 plus 9 plus 13 plus 17 plus
Plus dot, dot, dot. I hope those books get here quick. You guys understand the difference between the sequence and series, though? Okay. Now, this is obviously infinite, right? This is also infinite. What if it did this? 3, 9, 15, dot, dot, dot. I don't know, 67, whatever. I'm just making it up. Is this a sequence or a series? It's a sequence. Is it infinite? No, because there's a clear starting point. So this would be called a, this would be a finite sequence. And of course, if I had 3 plus 9, thank you, plus 67, then this would be a finite series. Yay! Thank you. You?
Wait, what page is that?
¿Ya tienes uno? ¿No te no, no? Cool. It's page. Thank you. Yeah, page 250. Swing better. All right, moving on. Okay, so number 2. Cross out the sequences that is not an infinite sequence. Which is not an infinite sequence? It's just the middle one because it actually stops, right? Now, 2 words that you guys need to know here, which is converge and diverge. Converge and diverge. So here's the definition. To converge means to come or join together. And diverge means to draw away or come apart. Simple enough? Converge comes together. Diverge goes away. So, they have a little true-false thing at the bottom. Number 3 says, a divergent infinite series does not have a sum.
True.
That is true. A divergent infinite series does not have a sum. Number 4, if 2 rivers converge, they do not meet. If 2 rivers converge, If they converge, they do not meet.
False.
That's false. An infinite series that has a sum is convergent.
True.
That's true. Okay, it's kind of the opposite of the first one. Number 6. When two lines diverge, they move away from each other. True. When two people share the same ideas, they're also said to have divergence of minds. That's false. It would be convergence of minds. Okay, cool. So those are the two big words that we need for today. Please have these with you. That's where those words coming from. I don't know if you guys have noticed, those of you that are still using it, a lot of these slides are in here. You guys are copying these slides, having this already. It's a waste of time. You don't have one? What happened to the one I gave you? Oh, can I give you a beat up one? Would you be okay with that? Yes, you do. Here, I'm going to give you my version of it. Here, pass this back. Pass this back.
No, I have it at home.
Okay, so you do have one. Here we go. I need to bring it. One day I'm going to do this. I'm just going to do points for who has it. Like, hey, here's the assignments. Do you have it? If you don't. All right, let's get to this. You guys ready? So that's what we're doing today. In the last section that we did, which was 9.4, we did the arithmetic series. The arithmetic series. Today we're going to do the geometric series. Okay? So things change a little bit. There's going to be some new formulas for you guys that we can get. Sorry, that you're going to have to just get used to. And we'll talk about the difference between those. Okay? We'll just get to it. Here we go. So, key concept. Notice I did underline up here something very important. This is talking about a finite geometric series. So, that means it's terminal. It has a beginning and it has an end. And if you want to find the sum of that, then you need this formula right here. You see it? I'm going to make it a little bit bigger for you. You guys can copy that over. So the sum of that is going to be a sub 1 multiplied by 1 minus r to the n divided by 1 over r. That is kind of crazy. But that means there are 3 things that you need to know. You need to know, oh, can't write yet. I'll let you guys finish that up. Okay? Probably T. Man.
I'll clean it if you give it to me clean it.
We'll take her right. Let's paper towels back. Just put this up a little more. Thank you. Okay, you guys got that copy? From this formula, there's 3 things that you need. You need a sub 1. This is going to be the first term. You also need r, which is the common ratio. And finally, you need n, which is the number, of terms that are going to be in this sum of sequence, or the series, I should say. Okay? So 3 things. Simple enough? Feels like it. All right. Cool, cool, cool. Common ratio. Ration. Common ration. Common ratio. Got your slide? G, you good back there? Get a fresh cut, G? Like Okay, so next slide then. Now, this one's a little bit different from the last one. The last slide was talking about a finite geometric series. This is going to be an infinite geometric series. Infinite geometric series. Yeah, go ahead and copy that formula down. Let's see if I can do that again here. Whoa. So here's what you need to know. There's going to be two types of, in two categories that these infinite geometric series will fall into. One of them is going to be the convergent, and the other is going to be the divergent. Okay, convergent and divergent. If it's convergent, can you find the sum?
Yes.
Yes, we just talked about that, didn't we? If it's divergent, can you find the sum? No. So you can't do that. So you need to know which is convergent and which is not convergent. Does that make sense? Simple way. You guys got this formula? Let me close that. Here's what you need to know. This is what you need to know right here. If the absolute value of the common ratio is less than 1, then you have convergence. That's an ugly one. Okay? If the absolute value of r is greater than or equal to 1, then they diverge. What am I spelling? These will have a sum. These will not have a sum. So once you find that the series there is divergent, you can stop. You don't need to continue. Okay? Got it, got it, got it? Don't got it?
So if the first one is greater than 1, it has a sum?
If the absolute value of the ratio, the common ratio, is less than 1, then they do have a sum. They converge. Okay, converges have sum, divergence do not. If the common ratio is greater than or equal to 1, then they're going to diverge.
So it can't equal to 1 either?
Yeah, if it equals to 1, it diverges. We got it all taken care of now. All covered.
Wait, is that after you find the answer?
No.
When you put
No, you're going to want to find the common ratio first. Because if the common ratio is greater than 1, the absolute value of that is greater than 1, then there's nothing to do. You will never find the sum of that. Because it goes on forever. Alright? You guys ready to do it? Let's do this. Finding the sum of a finite geometric series. Let's start with the finite geometric series. Okay? So here I have this. Please watch me do this, and then you guys can copy your hard content. And I'll give you another example for you guys to work on your own. Okay? So here we go. If I want to find the sum of this, I need to make sure that I need A sub 1, I need R, and I need, what else? N. How many there are? Okay? Now, should I find the common ratio and make sure that it's not divergent or convergent here? No. No, not here, because here it's a finite series, okay? So if it's finite, I don't have to worry about that. Only if it's infinite. And you can kind of think about it. If it's a fixed set of numbers, then I should be able to add them, right? But if it goes on forever, well, if the numbers are getting smaller, then yeah, I can get to the sum of that. But if the numbers keep growing forever, I'll never get there. Okay? So keep that in mind. So I need A sub 1, I need R, and I need N. Well, what is A sub 1? It's just 3. It's the first one, isn't it? Can anybody see the common ratio?
times 2.
It's going to be how much?
Times 2.
Common ratio. This is not an arithmetic. This is geometric.
Multiply.
So I'm going to take 6 and divide it by the previous one. That gives me 2, doesn't it? 12 divided by the previous. That gives me 2. 12 divided by the previous gives me 2. So my common ratio is 2. Common ratio. Fraction. Okay?
That's what I said.
Good. So it's 2. Now, how many numbers do I have? That's a little bit tougher, isn't it? Okay? This is going to be probably the toughest part. So let me get rid of this. In order to find this, I need the explicit formula.
Oh,
I need the explicit formula. This is not common difference times n plus something. That's arithmetic. Okay? If you don't remember how to find the geometric one, that's going to be a sub 1 multiplied by the common ratio to the n minus 1. That'll get you to that formula maybe about 90% of the time. And it's not that hard. Here, let me show you. What is a sub 1? It's 3, isn't it? And then what is my common ratio? 2. So that is going to be 2 to the n minus 1. And there's my formula. I'm done. Let's see if it works. You want to see if it works? Let's test this guy right here. What n is he?
4.
That is n4, right? So 3 times 2 to the 4 minus 1. That is 3 to the 2 times 2 to the third. 2 to the third, that is 8. 3 times 8 is 24. So my formula works. Right, Jacob? Yeah. So here's the deal. I need to know what n this is, because that's my last one, isn't it? Now, unless you're like gifted and can look at this formula and say, oh, this value of n gives me that number. I'm not that guy. So I'm going to take the same idea. I know that if I plug an n in, it'll give me a solution, won't it? Or a term in my sequence, in my series. I'm going to do the same thing. I'm going to ask the question, when does this formula give me 3072? Okay? And then I'm just going to math it from here. Do some algebra. Divide both sides by 3. That gives me 2 to the n minus 1. And this is going to give me, let's see, 3 goes in there 1 time, 0 times. How many times does 3 go into 72?
2. Oh no.
Yeah, it goes in there 2 times. I would have a remainder of 1. So 3 into 12 goes in there 4 times. So there it is. 1024. Good job. Thanks. I kind of spaced for a second. So here's what I know. Now again, I'm not that guy that can just look at this and say, oh, the degree here would give me, that gives me 1024 is blank. So 2 ways you can do this, but they both include logarithms. Okay? I'm going to show you the way that I would do it because it makes more sense to me. Is to go ahead and introduce log, correct? So let me do it on the next. I'm going to introduce log, so this becomes the log of 2 to the n minus 1, the log of 1024, okay? The reason I want that is because I can now take this exponent to the front, can't I? That is n minus 1. And this is gone. Because what did I do? I used that power rule to kick it to the front. I'm trying to solve for n, so I'm going to divide both sides by the log of 2. This is the log of 2. There we go. So this is 1, and I've got n minus 1 is equal to, I don't know. Let's see here. Calculator. Let's clear this. What is the log of 1024 divided by the log of 2? And that is 10. All right, cool. So I'm going to go over here. This is 10. How do I get n by itself, people? Add 1. So add 1. So that means that there are 11 terms here. You see how it all starts to kind of build up and sorry, questions right now? Questions at this point from anyone?
I think I got the rest except that part.
Except what part? The log? Let me show you another way you could do this, okay?
You already done it.
Let me go ahead and scratch this.
No, wait.
Okay, I can wait. That's fine. Something else you could do? Go ahead. You could stand back there. Have we been here for half an hour? Yes. The time flies when you're having fun. Can I get rid of this now? No? Okay. We just found that, didn't we? Steph? How about now? Can I see that? No?
How are you so hyper?
I'm trying to wake myself up. I'm just kidding. Dude, how can you not be hyper? You're doing math. 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 Yay, math. Now, I'm good? All right, so let me show you the other way you could have done this. Doesn't mean that's the way you have to do it, but some people like that better. Personally, for me, that's what I would go to. I'll put that over here. But let's say you're at this point right here, right? If you remember how to do the changing from powers to logs, then that's what you'll do. This would start off by saying log base what? 2. Log base 2, answer 1024 is equal to the power of n minus 1. And then to get n, what would I have to do? Just add 1 to both sides, right? So I would go plus 1, plus 1. So this would become log base 2, 1024 plus 1 is equal to n. And you can punch that in your calculator as well. Check it out. That log base is in math, up twice. So there's log base. Log base 2, 1024, plus the 1, and n is equal to 11 again. Okay? So either way you want to do it. There you go. Yes, otherwise you're like feeding into that and it's going to happen. It's called a self-fulfilling prophecy. Have you never heard of self-fulfilling prophecy?
What's that?
When you say something's going to happen, it happens. So like if you get up in the morning and you say, I'm going to have a great day today, guess what happens?
Oh,
You have a great day.
I was.
You know what I say every morning?
I say that.
I'm going to go do some math.
I was having a good day.
And then what? Oh. I'm not twisting the dagger. Okay. Now, that doesn't make us done. That was only to get n.
I thought we found the end.
Yeah, that was to get n, right? I just showed you a different way of getting n. So that's up to you. What I'm after is the sum of that, correct? I've got everything I need. I'm switching to green, guys. Here's how I find the sum. I'm going to take the first one. Here, I'll write the formula one more time. It is a sub 1, 1 plus r to the n, and that is over 1 minus r. That is the formula that I need. So I need to take 3, 1 minus 2 to the 11th power, and divide that by 1 minus 2. That will give me the sum. That will give me the sum. Now, heads up. Don't do that by hand.
Oh, never mind.
Did you see it?
Yeah.
That is huge. 2 to the 11th power. Let your calculator do the work, okay? And here's how I would punch into my calculator. You guys ready? Hold up. Go ahead. Okay. So, calculator. Now, what I like to do is I like to keep the numerator together. So I'm going to do something like this. I'm going to go something parenthesis divided by the denominator. Does that make sense, everyone? So everything that's in top is going to go inside of here. Everything on the bottom is going to go inside of there. So it looks like this. 3 parenthesis 1 minus 2 to the 11th power. Close that. Close the numerator. Divide by 1 minus 2. Close the denominator. And the sum is 6,141.
Wait.
That's not hard. It's not hard. Do you want to know why it's not hard? We already did all that before. The third section was geometric sequences. We did logarithms a couple units behind. So it's just putting it all back together again. So we're not doing anything that you haven't already done before. Okay? Can I change the slide? Yeah? All right, cool. Let's move on. Let's have you guys do one. I'll give you guys an easy one, okay?
Better be easy.
Better be easy?
He's gonna say it's easy, it's gonna be hard.
No, why would I do that?
Because that's how you are.
That's how I am? Ah. Why do you hurt me? Here we go. Okay, chill. What happened?
He just killed herself.
Why are you... no. This is obviously a finite geometric series. No, see, I can see why you think this is hard. No, you're not. Stop and think about, because we talked about this, didn't we? Here, let's do this real quick. I want to find the sum of this, correct? That means I need to take a sub 1 minus r to the nth, over 1 minus r. That means I need 3 things. What are those 3 things, people? A sub 1, I need r, and I need n. Okay? What does n equal? It does not equal 0. N is how many numbers there are. How many terms in the sequence, in the series?
20.
It's not 20.
4.
It's 21.
Why?
Where are we starting at? We're starting at 0.
Okay,
1 to 20 is 20 numbers. But if we start at 0, how many terms are there?
21.
21. So n is 21. Now, do you guys remember that formula I gave you guys a minute ago to find the explicit formula? It was a sub 1 times common ratio to the n minus 1. Correct? Look at this. A sub 1, you see it? Common ratio to the n minus 1. They gave me everything. What is a sub 1, people? 4. What is my common ratio? 1/2. All numbers are there for me. Just plug them in. Just plug them in and have the calculator do it. So this would read 4 times 1 minus 1/2 to the 21st power over 1 minus 1/2. Okay? Right? Okay, no. You could do this. This is good to do. You need to understand this process. But what made me like kind of tear up a little bit, was that nobody recognized. What is this called? It had a specific word. Started with S. It's a summation. It's a summation. Mr. Munoz, I know how to do summations. They look like this. Boom. Now, let me recommend this to you real quick. Because some of you guys are going to want to just go straight here and depend on this. Because I could just go, oh, that is, I'm going to go x instead of n. Start at 0. I'll go up to 20. And then my formula reads 4 times 0.5 to the 21st power. Forward. Close that off. And then I press enter. And I get approximately, oh, that's not correct. What was it? There was 21.
Oh,
What did I do wrong?
isn't the 4 supposed to be by the
Let me go back up here. Second entry. Let me try this again. One thing that we did find though, guys, you can't have enough parentheses here. You just can't get enough. Oh. What's supposed to go in there, guys? Not 21. What am I thinking? It's supposed to be X. I'm plugging in the formula, and I'm not doing it by hand. So delete, and then we'll call that X. Here we go. So it's approximately how much?
8.
It's approximately 8. Now, back to what I was saying. What's the technology for? Get answers real quick, right? That should help me when I'm doing this to check my work. If you're doing your test and you just spit out the answer, kind of like what I just did, didn't I? Didn't I just do something weird? And I got something weird out of there too? I know for a fact at least 40% of people will write that on their paper or punch that into Math Excel, and you got it wrong. Guess what? You fools. You just lost points, okay? So, use this to check your work. Now, if you turn in the work, say, hey, I had it right, Mr. Williams, look, it's right here. Which work are you going to show me? What am I going to look for? I'm going to look for this stuff. And if it's not there, you just lost points. Okay? Alright, we're good? Thumbs up, thumbs down. Got it, don't got it, sideways. A little bit. It's going to take a little bit of practice. Okay, cool. I'm not sure what that is. Alright. Sorry. Don't hang me.
Lucas, what do you do for spring break?
I want to go camping. Up a flag.
Wait, Mr. Munoz, you see how it's cut off right there by the evening?
Yes.
What is that?
That was the instructions from right here, see? It said, I copied this picture here and I pasted it there. So it said, what is geometric series? So that's the end of the S. See it? Does that bug you?
Just a little
Just a little
bit.
bit? Here, let's fix that. You're most welcome. Can I change the slide? No. No changing slides.
Wait, how did you get there? Oh, you
How did I get what?
pushed math is really
My calculator?
Yeah.
Math, and then you went to summation. So math, summation, which is option 0. But there's log base also. Okay? Good morning.
I got you. Just kidding.
They need me to sing. Good morning to you. Our day is beginning. There's so much to do. All right, cool. Analyzing infinite forever geometric series. You guys ready? Here's the first one. Before I even attempt it, I need to know whether this is going to converge or diverge, because if they diverge, then I'm done. Hooray, hooray. Right? So let's do this. Ready? How do I find a common ratio? How do I find common ratio?
Divide the 1 before it by 1.
N plus 1 by n. So I'm going to take 1/2 and divide it by 1. Oh, that's nice. What's half divided by 1? It's a half. Anything divided by 1 is itself, right? So let me double check that with this one. 1/4 divided by 1/2. I multiply by the reciprocal. That becomes 2/4, which is 1/2. Yay! So absolute value of 1/2. Is the absolute value of 1/2 less than 1?
Yes.
So that means that they what?
Wait.
They converge.
Oh, yeah.
Converge. This is less than 1. True, they converge. So that means that I can find the sum. And how do I find that sum? It's just like the last formula, like this. But except, I don't need to do the 1 minus r to the n's. It goes like this. Okay? Here's my formula for finding the sum of an infinite series. Infinite. Infinito. Simple, right? What is my first term? 1. And if I go 1 minus the common ratio of 1/2, that means that I'm going to take 1 over 1/2. So what's half of 1? Oh, sorry, how many pieces would I get if I took 1 and I cut it in half? I would get 2 pieces, wouldn't I? So guess what the sum is? 2.
Wait, what? Oh, the sum.
Yes, the sum of this infinite series, because it goes dot, 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 dot.
What does the T stand for?
What does what stand for?
The T cover.
True. T for true. T for true. This statement was true. It was true. So therefore they converge. We got some confused faces up there. Which part? G?
Yeah.
Which part?
Oh, no, I'm good.
You good?
Possession is fine.
Nice. Good then. Show me how good. Show me fist of 5. Okay. Let me just run this real quick. This is an infinite series. That means it goes on forever, right? They got dot, dot, dot here.
No, it doesn't.
Yeah, well, I didn't copy the dot, 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 but it goes dot, dot, dot. It goes on forever, okay? I have 2 choices. Either this is going to converge, either it's going to converge, or it's going to diverge, okay? If it converges, then I can find the sum. Sum, yes. If it diverges, sum, no. So I would be done at that point. What I need to do is find that common ratio.
Wait,
If
so
it-
if it diverges, you just do
I just done. Okay, there's no, because think about this. And this is how we know. Here's how we know. The rule says, I want page width. The rule says, you know what? If this ratio, the common ratio, okay. So if they converge, it's going to be the common ratio, the absolute value of the common ratio will be less than 1. Okay, whether it's positive or it's negative, we're just going to find the absolute value of that. If it is greater than or equal to 1, it's going to diverge. And here's what I want to talk about. Think about this. We're multiplying that common ratio, correct? based on the explicit formula.
Mhm.
So if I take a number and then the number gets bigger, okay, then the next one's going to be even bigger still, correct? And what happens to all the numbers? They just keep getting bigger, 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 bigger. There's no way for me to ever know how far up or big they'll get. I'll never be able to add those
Were
up.
the questions ever asked like, what's the sum of this point to this point?
Then that would be, yeah, that would be a finite.
But if it's like continuous,
Then that's why I need to decide too also, is it finite or is it infinite? If it's finite, then I can find the sum. Because that means there's a fixed set of numbers, correct? It goes from here to here, add them up. But if it's infinite, then I need to know one of these two things. Go ahead.
What if it's just greater than and no equal?
It's either one. This is kind of two things there. It could be one or it can be bigger than one. They still diverge.
I know, but would it be diverge if it was just greater than?
Yeah, that'd be fine. Because this is a two-part, it's a two-part inequality. But let me tell you what if it makes sense for convergence. Let's say I had numbers 1, 2, 3, correct? And kind of like in this example, what happens? The fractions keep getting smaller, don't they? But will they ever get bigger or bigger than 2? The fractions.
No.
Will they ever get smaller than 1?
No.
So I kind of, even though it's infinite, because how many fractions can I get in there? I can get a lot of them, couldn't I? I can always take half of the next one. But if you think about this, it's closed between 1 and 2, isn't it? So even though the number of fractions there is infinite, it kind of is locked in position, isn't it? Between 1 and 2, which is kind of mind-blowing. That's really cool. Like, I've got this infinite set between 1 and 2 that goes on forever, but I can still find the sum of that. All right, anyways, so we need to decide these two things, China. If it does diverge, I'm done. And if it converges, then I've got to find some of them. So, next logical step, we found that they did converge. So I find my formula, which is a sub 1 divided by 1 minus r. The first term in that sequence was 1. The common ratio was 1/2. At this point, it's just math. Just arithmetic. Okay? If I have 1, I take away half. I get a half, don't I? And then do I divide by fractions? No, I multiply by the reciprocal. So this is 1 times 2 over 1, which becomes 2 over 1, which is just 2. Okay? All right, cool. Here's the whole enchilada. Questions on any of it? Ask now or forever be confused. Moving on.
Wait.
Okay, sorry. You guys make me wait so I can calm down, huh? And like chill again. Good looking out. Good looking out.
is your
I don't think you need coffee.
Hmm?
Said I don't think you need coffee.
Oh, coffee doesn't affect me.
It puts me to sleep.
yeah, I drink coffee before I go to sleep.
I tried.
Different reasons, but I just like the taste of it.
What kind do you drink? Do you add like sugar and stuff, or do you drink it?
I used to only have sugar in it until I met my wife, and now she was a creamer only person. Like she only put cream in her coffee, and I only did sugar in my coffee, and of course, not straight in heaven, not sugar and coffee.
Sugar and coffee, you mean sugar and cream?
Not sugar and cream, yes. Sugar and spice and everything nice. Even though right now she's getting me hooked on those little, what do they call the little delight cups? The little,
Yes.
with the hazelnut in it.
Yeah.
Oh my god. Hazelnut is so good. Nom 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 nom. Nom 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 nom. But personally, I'm a dark roast kind of guy.
I like black.
I like dark, bitter coffee. I told you guys, right, of one of my students. I I also like dark chocolate. You ever have dark chocolate?
Yes.
So I go to World Market because they have 99%. Yeah, 99. And I gave a piece to a student because she liked dark chocolate too. And she just takes a piece of chocolate from her and she's like, dark and bitter like my soul. I cried laughing. That was so funny. So every time I think of, I have something like dark and bitter, I just remember her. I'm never gonna forget. Can I change slide now? Dark and bitter like. Okay, now you go. Now you go.
Is that a 5? What is that?
That is a 5. Hold on. Hold on. Hold on. Hold on. Hold on. Hold on. I don't want people to get. Okay, go.
So what does it say above the?
I want you to find. I want you to find the.
Oh, that's an infinite series?
Oh yeah, up above the sigma.
Yeah.
That's from 0. Yeah. So that just tells me that this is an infinite series, correct?
But what does it say?
That's not a 5. It's an 8. It just kind of fell over. It's the 8 trip.
No,
Does it get on your bag?
no.
Holy smokes. It doesn't even look like it, does it?
What is he doing?
Well, like if I didn't see this foot, I would be like, oh wow. Holy smokes. Oh wow.
What is that shoe you wear?
You did not really try to put my shoe on. Do it. But it's like this big.
Questions before we get started. Does this converge or does diverge?
Diverge.
You know what? Let's have the dojo pick someone.
No, that's fine.
No, that's fine. I know the answer. What is it?
No, go ahead.
What is it? 5 minutes left? Oh no, that was your time for the. She said yes. I'm off the hook. Yanira. We do? Sorry, Yanira. This it diverges. Think back to the formula I gave you. A sub 1 times r to the n minus 1. I'm looking for this common ratio. It's this number. The absolute value of that is 5/4. Is that bigger than 1?
Yeah.
Diverge. So can I add these? No. Done. Guys, that's all I have. No, I had one more. Please make sure you do the exit ticket before you head out.